Hi, I'm going to try to work through some problems here with you on the board. Um, this is a flattering angle of me. So we are up close and personal, but I'm going to try to work these out on the board and not go out of my space here. So we'll see how I do. But with dimensional analysis, you basically just have to set up your boxes, and then whatever unit is in the top corner is the same unit that comes down and over. And then what is up and down from there on, it has to be equal to each other. So if I did um, just like a basic one, so let's say I need to convert centimeters into feet. Okay, so if I have centimeters, let's say I start out with 5 centimeters, and that's what the problem gives me. It says you have 5 centimeters of wood, and you need to know how many feet that is. So you would start with 5 centimeters. Centimeters is the unit. Okay, so that unit has to come down here. We don't know what number we're going to put with it yet. We're just going to write the unit in and then kind of go from there. So we'll put centimeters down here. The reason why the units have to go down and across is that in the process of solving this, you're canceling out those units so that we're converting it into the new values. So here we're going to have centimeters and centimeters. Now the fact that this is a 5 doesn't matter. It could be 67. It really doesn't matter at this point. We just have to figure out what our next conversion step is going to be. So if we have centimeters down here, our end goal is feet. We don't have a nice clean conversion between centimeters and feet. But if you think, you're okay, what's the next step I could do? You could go from centimeters to inches and then inches to feet pretty easily. So for centimeters to inches, okay, we have to know what the conversion is between these two. All right, so there's going to be 2.54 centimeters. That's a point, okay, for every 1 inch. So we're just going to write in a 1 there. So at this point, centimeters have canceled, okay? Now we're in inches, which is good because we want to get to feet, right? So now that we're in inches, you have to have inches down here. There's no other option. So you have to, whatever unit you have kind of up here, the catty corner unit has to be the same. So I know I'm going to have inches down here. Now you want to think, okay, can I get from inches to feet? Yes. So we can put feet up here and then write in the conversion factor. So whatever's on top and bottom, this has to be something that is equal to each other. Okay, so whether that's kilograms to grams, meters to milliliters, whatever you've got going on there, the top and the bottom have to be a conversion to each other. That's why we have a 1 and a 2.54 here. And so here, you know that there's 12 inches in every 1 foot. So if you go back in again and say, okay, now these inches have canceled. Now I'm in feet, okay, which is where I wanted to be. And you're done with the dimensional analysis part of this now. So you just have to solve for it. So what you're going to do to solve is take everything on the top and multiply it. So all these will be multiplied. And then you take everything on the bottom and multiply it. Okay, so you end up with something over like this, and you'll divide that for your final answer. Okay, so in this case, you'd have 5 times 1 times 1 divided by 2.54 times 12. Okay, and that's going to give you how many feet are equal to 5 centimeters. Okay, so obviously it'd be a small number just because we know that feet are a lot bigger than centimeters. So if we switch this up and do this like one of our problems from our assignment, let me just get that pulled up here real quick. Okay, so I was trying to just pull this up on the screen, but I guess since I started it as a webcam, I can't undo that. So I'm going to go ahead and do this one with you. So it's the second one, so it's number 2 on the assignment. Okay, so it's the one that talks about ethylene gas reacts with carbon dioxide. So for this, for stoichiometry, you're doing dimensional analysis, but you first have to write out the formula in the equation and then balance the equation, get your mole ratio, and then you can divide. So the mole ratio, it's just the coefficients that you put in, and then you're going to use that as your conversion factor. So it'll be whatever's on top versus on bottom. So I'm going to go ahead and erase this and use this space. So for this one, let's see here. So we have ethylene reacts with oxygen gas to produce carbon dioxide and water. And then it gives you some more information. So first thing we have to do, let's get this up in here, is write out our reaction. So this is ethylene. It gave us that as part of the question. Ethylene and oxygen gas yields carbon dioxide and water. Okay, so at this point we have to go back in and balance that out. Okay, so we know that there's, you'd usually want to start with carbon, right? You want to leave your oxygen and hydrogen until the very end. So we have 2 carbons here, 1 carbon here. I'm going to go ahead and stick a 2 here to balance out the carbons. So now if I'm looking at my hydrogens, I have 4 hydrogens here and 2 here. So I'm going to have to put a 2 here as well to balance out my hydrogens. Now I have to figure out my oxygens, right? So I have 2 times 2 plus 2, right? Because this 2 goes here. So we're going to have, 4 plus another 2. So I have 6 total oxygens on this side. So I'm going to need to put a 3 in front of this to make that balance. So now what we have is all these coefficients in front. You know that this is like a 1. You don't have to write the 1 in. There's 3 moles of oxygen. There's 2 moles of carbon dioxide and 2 moles of water. So now we can use that to find our mole ratio. So in this question, it's having you compare ethylene with carbon dioxide. So as far as the mole ratio goes, you only need to look at ethylene and carbon dioxide. So that's this one and this one. Okay, so the mole ratio between those two is going to be 1 mole of ethylene to every 2 moles of CO2. Okay, so that's our ratio. That's what we can use to convert from ethylene to carbon dioxide in the problem. So this problem is going to go on, and I need you to figure something out. So this is where we're going to use dimensional analysis is at this point now. So it says if you start with 45 grams of ethylene, how many grams of carbon dioxide will be produced? So we're going to start out with, let's see, the 45 grams. So we start out with 45 grams of ethylene. Okay, 45 grams of ethylene is going to be like our first box of the first part of the table. Grams of ethylene has to come over. So we're going to go ahead and write in grams of ethylene. Okay. And at this point, we got to figure out, okay, we need to get to carbon dioxide. So in order to switch the unit from one substance to another, you have to get to moles first, okay? So we're in grams right now. We need to convert this into moles so we can use this mole ratio to convert it from ethylene to carbon dioxide. So what we're going to have here is the mass of this ethylene. So we're just going to add that up from the periodic table. So 2 carbons plus 4 hydrogens is equal to 1 mole. So we know 1 mole of anything is equal to its mass. So we know we're going to have 1 mole of ethylene. And the mass of this was 28.05. Okay, it's a little messy. Hopefully you can read that. So now grams of ethylene are done. We've canceled that out. Okay, now we're in moles of ethylene, which is great. We're moving in the right direction. We need to get into moles of carbon dioxide at this point because our end goal is grams of carbon dioxide, but we have to go from moles to grams first. So we have moles of ethylene. So we know that moles of ethylene has to come down here. Okay. Now you have to do the conversion between ethylene and carbon dioxide. So we have this, okay, that is the mole ratio. That's our conversion factor. Okay, so for every 1 mole of ethylene, there's 2 moles of carbon dioxide. So at this point, we're just going to write in a 1 down here for 1 mole of ethylene, and then 2 moles of carbon dioxide here. Okay, now you're in moles of carbon dioxide, which is awesome. We're almost done. So moles of ethylene cancel. We're in moles of carbon dioxide, so we're going to put moles of CO2 down here. We need the mass because that's what the question was asking for. So it wants the mass. We know, again, like just like we did on this side, 1 mole of anything is equal to its mass. So we're going to have 1 mole of carbon dioxide is equal to its mass that we're going to get from the periodic table. So you're going to add that up. It'd be 1 carbon and 2 oxygens. So it's at 44.01. grams of carbon dioxide. So now your moles of carbon dioxide have canceled. You're in grams of carbon dioxide, which is what the question's asking for. And at this point, we're done. So here, now all you have to do is multiply everything across the top, multiply everything across the bottom, and divide them. So for this one, you should end up with 141.2 grams of carbon dioxide. Okay. So this is the whole thing. But this is number 2 on your assignment for intro to stoichiometry. So it's the first part of like actually doing the stoichiometry on your own. So number 1 is going to be really similar to the last example in the notes. So I think it's example 2 under the first day of stoichiometry. And then this is number 2. So you should be okay on 1 and 2. Give 3 and 4 a shot and let me know if you still need any help. But hopefully this is helpful for you. Please remember to keep track of your units. Okay, I know it's lengthy, like it's kind of a pain in the butt to have to write out like grams of ethylene and all this throughout. But if you don't write that and you don't label it every time, hopefully you can see how that would be really easy to lose track of where you are. So that's I'm telling everybody to do that. Just I know some people just really hate labeling things because it takes a little extra time, but it's important. So like if you just had like 45 and 28 and 1 here, you have no idea what you're talking about or what units you're using. So important to do that. So please let me know if you do have any questions, and I'm happy to set up a Zoom meeting or anything else if you need it. So let me know how it goes.